Good morning, friends. Let us say no. First of all, welcome back to our original schedule. Original schedule means in last week we have seen the revision of chapter number 3, but from this date means 1st June 2020, we are going to start second part, and in the second part of physics we will see the chapter number 12, and the name of chapter number 12 is atoms. Mind well, it is a very nice, short and very sweet chapter. Not only chapter, it is a very nice part number 2, because it having so nice theories as well as easy numericals, so it is very easy to grab, to obtain the marks from this part, especially part number 2. Okay, so in this chapter number 12, atoms, let us see first topic, and the first topic is about alpha scattering. Alpha scattering was discussed with the help of experiment. That experiment was made by two scientists, Geiger and Marsden, right? Under the observation of that Rutherford. So Rutherford in 1911, he told to that two scientists, Geiger and Marsden, please perform some experiment which gives us the information about alpha scattering. Which was the experiment? What they have taken? Let us see. Okay, in this experiment, that is Geiger-Marsden experiment, there is a source of alpha, and that source is taken as bismuth. Got it? This bismuth is excited by giving some energy, and that energy is 5.5 MeV. So bismuth is a radioactive substance which is excited by energy 5.5 MeV. This bismuth emit alpha particles, right? So it emits alpha particle in all the direction, but we have to make a narrow beam. Narrow beam means that light of a razor, right? So that narrow beam of alpha particle is made with the help of lead bricks. So you have to put the lead bricks to make the alpha particle as a narrow beam. So this is a lead brick. Brick, not brick. Bricks. These are the lead bricks which made alpha particle a narrow beam of alpha particles. This narrow beam of alpha particles get incident on a gold foil. So this is a gold foil. Isn't it? So it is a gold foil and this gold foil is very thin, and the thickness of the foil is 2.1 multiplied by 10 raised to minus 4 meter. Okay, let us see once again. Bismuth, a radioactive substance, it is excited by energy 5.5 MeV. This bismuth emits, what it emits? Alpha particles in all the directions. This alpha particles is made in a narrow beam. That alpha particle is converted into narrow beam with the help of lead bricks. This alpha particle get incident on a gold foil whose thickness is 2.1 multiplied by 10 raised to minus 4 meter. Okay, so these alpha particles get scattered in all the directions. So after incident on that gold foil, it scattered in all the directions, and that scattering of alpha particle is observed by the rotating screen. So this is a rotating screen. There is a rotating detector. Okay, and that rotating detector is connected with microscope. This is a screen of ZNS, means zinc sulfide screen. Okay, so this is the arrangement of that Geiger-Meridian experiment for alpha scattering. Okay, once again, if you want to see, then it is like this. Say, bismuth, a radioactive element which is excited by energy 5.5 MeV. It emits alpha particles in all the directions. These alpha particles are collimated in a narrow beam with the help of lead bricks. This narrow beam of alpha particle get incident on a gold foil. The gold foil is very thin, and the thickness of gold foil is 2.1 multiplied by 10 raised to minus 4 meter. Okay, there is a rotating detector and microscope which is used to detect flash of light. What is mean? Right? So when alpha particle gets scattered and this alpha particle collide with that zinc sulfide screen. So when alpha particle get collide on the screen, it shows some flashes of light. And that flashes of light is detected by the rotating detector. Got it? And from the record of that flashes of light, we come to know the scattering of alpha particles. Okay, so this is the practical arrangement of Geiger-Meridian experiment. The question will be like this. Explain or give the practical arrangement of Geiger-Meridian experiment for alpha scattering. So this is just the practical arrangement, and after that we will see the conclusion, and the question for conclusion will be different. Okay, let us see for few seconds. Okay, now come back here. You will find that there is one angle theta. It plays very important role in that conclusion. Okay, first of all, if you will see the figure in our textbook, there are alpha particles in which scattering is very less, means only 0.14% of alpha particles. Scattering of alpha particles is only 0.14%, means what does it mean? See, suppose alpha particles are emitted, it got incident on that gold foil. There is a less scattering of alpha particle, means only and only 0.14% of alpha particle having less scattering, right? So here scattering is less. For most of the alpha particles, means almost all the alpha particles are going straight without any scattering, means only 0.14% of alpha particles from the total is scattered, and at that time scattering angle theta is how much? Less than 1 degree. So it shows that alpha particles having positive charge and they are moving forward without any scattering, means inside the atom there will be an empty space. What that empty space called, that we will see later on. Okay, now contradicts of this, there are alpha particles which are rebound back. How much alpha particles rebound back? 1 to 8,000. They rebound back. Why rebound? Because of that same logic, plus plus repel. Means here there are some charges which having positive charge. Why? Because alpha having positive charge, there are some charges inside the atom which also having positive charge, and because of that plus plus, alpha particle repel, and because of that it rebound back, means this portion it having less on, and here there are more scattering of very less alpha particles. Got it? And here the angle of scattering is more than 90 degree. Got it? If you will check the degree here, theta is equal to 0, it is 90, and it is more than 90. So very less amount of alpha particles having more scattering means how much alpha particle? 1 to 8,000. And for that more scattering, angle of scattering is greater than 90 degree. Why 90 degree? Why more scattering? That we have seen. Clear? Plus repel. So it is the case of nucleus. After this, Rutherford suggested that inside the atom there is some region where there is a positive charges, where the entire mass of an atoms are concentrated, and that region is at the center, and that is known as nucleus. So because of that, nucleus was invented by Rutherford. We are going to study. We are usually saying that nucleus was invented by Rutherford from the experiment of Geiger and Mersenne. From the conclusion of this means here at the center all positive charges are residing at the center. Entire mass of atom is present, and that region, that is known as nucleus. Clear? So it is the end of the conclusion of Geiger-Mersenne experiment. Let us see conclusion once again. When narrow beam of alpha particle get incident on a gold foil, right? The scattering of alpha particle is observed by the rotating detector and microscope. It is concluded that 0.14% of entire incident alpha particles having less scattering. Most means most of the alpha particles comes out without scattering, and the rate of scattering in such type of alpha particles are only and only 0.14%. It indicates that inside the atom there is an empty space. It is the first conclusion. What is second conclusion? So, few of the alpha particles, that is 1 to 800 alpha particles, are rebound back from the region where the scattering is more, very less amount of alpha particles which are having more scattering, and the scattering angle is more than 90 degree. It means inside the atom there is a region which having positive charges. So because of that, alpha particle plus, it is also plus, it rebounds back. And from which region it rebounds back? Where the entire positive charges are concentrated. Entire mass of an atom is concentrated, and that is known as nucleus. Clear? So these are the two conclusions, and from that conclusion we can say that nucleus was invented by Rutherford. There are few things about the size of nucleus. After this conclusion, Rutherford gave information about the size of nucleus. The size of nucleus is about 10 raised to minus 15 meter to 10 raised to minus 14 meter. Ready? Size of nucleus 10 raised to minus 15 to 10 raised to minus 14. Size of atoms according to that kinetic theory. Size of atom is 10 raised to minus 10 meter. Clear? Third thing. The size of nucleus is very less. How much less? 10,000 to 1 lakh times less than size of atom. Means whatever the size of atom is there, of that size, how many times? 10,000 to 1 lakh times less size that nucleus have. Okay? Here we have taken one word, empty space. Where is that empty space? Okay? So, between nucleus, around the nucleus, there is a space, right? Electrons are revolving around the nucleus in an orbit. Between the first orbit and the nucleus, whatever the spacings are there, it is known as empty space. And from that empty space, alpha particles come out. Most of the alpha particles come out with less scattering. Is it? Okay? And the distance between nucleus and first orbit, the distance between nucleus and first orbit is also about 10,000 to 1 lakh times the size of nucleus. Okay? So, dear students, you must have to refer the textbook. Why? Because these are the theoretical topics. It may ask in your exam, it may not ask in your exam, but these topics are very useful for logical questions as well as MCQs. So, you have to go through that textbook, part 2, mind well, part 2, chapter number 12, and you have to underline that few important points which is useful for our MCQs. Okay? Enjoy. Have a nice day.